Find an expression for the area under the graph of f as a limit given f of x equals the square root of sine of x and x ranges from 0 to pi. Now we have different formulas for the area under a curve. We could use right-handed rectangles, left-handed ones, midpoints. We could use generic ones where we put a little asterisk on our x's, but let's use right-handed rectangles. It's generally the easiest as far as formulas go. We know that the area underneath the curve is given by the limit as n approaches infinity of the sum as I ranges from 1 to n of f of x sub I, delta x. We also know that delta x is always given by b minus a over n. That's the width of the interval that we're looking at, divided by the number of rectangles. And we know that x sub I is equal to a plus I delta x, which is b minus a over n, but we'll get there. So let's actually plug these things in for this particular function. So we've got the limit as n approaches infinity of the sum as I ranges from 1 to n. Now we have to evaluate our function at x sub I, and our function here is the square root of sine of x. So we've got the square root of sine of x sub I. So we're going to need to put x sub I in here, but we have an expression for that. It's a plus I times delta x. A is the starting endpoint, which is 0 here. So we've got 0 plus I times delta x. Delta x is b minus a over n. In this case, that's pi minus 0 over n, which is pi over n. So we've got pi over n in here times I, right? Remember, we've got that I times delta x. So that's I times pi over n. And that is the inside, and then we have to multiply that by delta x. But we already saw delta x was pi over n, so we've got to put a pi over n out here. And so that ends up being our sum. We've got the limit as n approaches infinity of the sum as I ranges from 1 to n of sine of our x sub I, which we saw was pi over n times I, times our delta x pi over n.